so that it's more accessible for you guys. But yeah, Matt has the copy of that. I'll bug him for that. Alrighty. Oh, got another person. Cool. All right. So let's do this thing. Okay, so first of all, I want to ask you guys, does anyone want to kind of volunteer, or who has not heard of a higher order function? It's okay if you haven't, because that's why we're doing this. You can like shake your head or nod or whatever. Cool. So
I just forget how you use them.
Yep. Wait, sorry, one sec. That's stupid. Okay, there you go, Bunny. You have it now. Okay. Okay. So a higher order function is a very simple concept. In its definition, it is just a function. It's a function that takes one or more functions as a parameter. Or sorry, that takes one or more functions as a parameter. Okay, so what that means, and this is just a basic, to go back to some very basic things in JavaScript. In JavaScript, you have things called values. Values can be numbers. They can be Booleans, true or false. They can be strings. Values can also be objects. They can be arrays, but they can also be functions. Okay, so here's an example of some function. Okay, so what this means, a value is just a basic building block of code. So all expressions in JavaScript resolve to a particular value. So whether that's 10 plus 10, that resolves to the value 20, right? Functions are a little bit more complicated types of values because they don't just represent some value like 10 or true or false or something. They represent a subroutine, meaning it's a set of instructions that it's just a block of code that can be executed at any time. But what's interesting is that recipe can be captured as a variable, right? So I could say something like const hello world is equal to a function that console logs hello world. Okay. So that means that this hello world function is now, that's a value. It just happens to be this function. So what's cool is that I can execute this function using the syntax of the parentheses. But what's really cool is that I can also capture it as a value. So right now I have it, I can capture it as a variable. So right now my variable is called hello world, but I could just as well do something like this. Some variable equals hello world. Okay, so now I could also do this, and this will also work. So we're going to go ahead and do node main.js. I'm going to get rid of some. And there it is. Okay, so I've defined a function called hello world. I've captured it in another variable, and I've called that variable. I could just as easily do this. Okay, and I'm going to see this twice. Notice I see the output of that function twice. Hello, Mia. So this concept is really important. This ability to just pass around function values or functions as values. That's different than talking about the return value of a function. Notice how this function right here doesn't actually have a return value. There's this, if I were to capture the return value of this function, and I console log output, this is going to be undefined because hello world, as you can see, does not have a return statement. Okay, so don't confuse the function as a value itself with the value that it outputs. If I wanted to, I could output something. I could be like return false, and then I would have a false output, okay? Okay, so how does this, so let's kind of step out for a sec and see how can we utilize this? So JavaScript is really cool because not every language is easily able to do what JavaScript can do, which is this ability to just capture functions as arbitrary values. And the fact that JavaScript can do this allows us to do some really cool things, such as use higher order functions. I spelled that wrong. Okay, so a higher order function is just a function that takes one or more functions as a parameter. So that would mean that I could write a function. Let's call it an answering machine. Okay, and this answering machine takes a function, which I'm going to call voicemail as an argument. So I'm going to assume that voicemail is a function. Okay, so we're going to assume that it's going to, so notice voicemail is not a string, it's not a number, it's not an array or anything. We're treating this as a function. This is a parameter to a function that is a function in and of itself. Okay, and we're going to assume that this function provides us with a message. So what we're now going to do, say, oh, and then we're going to have a caller be a sorry, I'm doing this backwards. Excuse me. All right. So what's happening is our answering machine is taking a voicemail from someone and then just telling us who called and what their message was. So caller called the message. This is a totally contrived example. We're gonna do some much more interesting ones in a second. Okay, so what this means is if I call answering machine, we know that it takes two arguments, caller and a voicemail. Okay, the caller is going to be Ben, and my function, my voicemail function, again, this is totally arbitrary. It's a function that's returning, call me back, this is important. Okay, so when I run this code, let's see what happens. Ben called, here's the message, call me back, this is important. Okay, it's kind of silly, kind of stupid, but the principle here is that I have a function, answering machine, which can take a function as an argument. This is a really powerful pattern. So we're gonna kind of actually take a look at how this is used in some real life examples. So in functional programming, in the functional programming paradigm, instead of, unlike object-oriented programming, where we're talking about inheritance and hierarchies of categories of objects, here we're simply talking about inputs and outputs. Okay, so a function at the end of the day is just a thing that takes input and produces an output. So the entire functional programming paradigm is based on that simple fact. And in JavaScript, because we can pass around values the same way that we can pass around strings and objects and arrays and stuff, allows us to do some very, very cool things. So have any of you wondered how the filter method works? So let's say I have some array, and I say const numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here's my numbers. Okay, suppose I want to filter out all of the odd numbers. Okay, what's one way I can do that?
You could use a for loop. Oh, sorry.
Yeah, I could use a for loop. I could say, for let I equals 0, I is less than the number's length, and then I could proceed to apply my logic, right? For each number, determine whether it's odd and place it into a new array. Right, I could just as easily do that. However, there's an easier way, and that's through the filter method. So the filter method is a method that belongs to all arrays. Every single array has this method called filter. Okay, and the reason why filter is so important and why it's able to, and why it's so useful is because it allows us to, it's a function which allows us to pass in a function which helps us filter out this array based on whatever rule we want, right? So I pass in an array, I pass in a function, and then this function determines whether to keep, throw out each element of the array. Okay, so how does this filter method work? It works because we're able to pass in this function as a value, and then internally, it's able to execute that function at will. Okay, so how many of you have just been kind of mystified or confused as to the fact, or as to how filter actually works?
Me for sure.
I know I was. It was always kind of, it seemed kind of magical to me that somehow the filter method knew that there was this value here and I somehow could do stuff with it. So we're going to look at how this actually works. So we're going to make our own pretend filter. Okay, we're going to make our own filter. And this is going to be a slight oversimplification of how the actual filter works, but it's going to effectively do the same thing. So, okay, how does filter work? A filter is just a way of saying, hey, keep this or don't keep this. And at the end of the day, we're just going to provide an array containing only the things that we want to keep, right? That's all a filter is. It's just you're just saying yes or no to every member of the input, and then you're providing an output that only contains the yeses. Okay, so we know that this filter is going to take some array as an argument, and then we're going to come, and then we know that it's going to provide a rule which determines whether or not to keep something in that array. Okay, so what we're going to do is, because at the end of the day, what we want to be able to do is say, and then pass in some function which determines whether these guys are odd. So what we're going to do here is we have to kind of assume that this rule knows what input it's expecting. We expect that this rule is going to take a single argument as a function, or sorry, it's going to take a single argument. And then we also have to make another assumption that it's going to return either true or false. Okay, those are the two assumptions we have to make. So we're going to write a for loop. The idea here is to loop through the array. And then we're going to, for each number, check if it passes the filter rule. And when I say passes the filter rule, this is where it comes back to that assumption I said we're making. The meaning of passing the filter rule means that that function, when given a particular number, returns true or false, or returns true. If it returns false, we're not going to keep it in the array. Does anybody have any questions so far about how this is kind of going to go? All right, I'll take that as a no. Oh, go ahead.
I just had a question about like parameters and arguments.
Yeah.
Like I always get confused on like when people use it, like because I have an idea, like I thought those two are like parameters, but I wonder if people just sometimes use them interchangeably as well. You know,
people do use them interchangeably, but it's actually incorrect to do that. There's a very subtle difference. So a parameter to a function refers to the variables that the function uses internally. So right now, filter, my parameters are these guys. Okay, so they're part of the definition of the function. Filter is the name of my function, right? It's the variable that I'm storing my function in. An array and rule are the parameters to that function. These do not have real values. These are the placeholders that when I execute my function, that's what these represent. And that's when they're called arguments. So when I actually call my filter function right here, see how numbers actually has a definite value? That is when these are now called arguments because I'm executing the function. So when I'm defining the function, they're called parameters. When I'm executing the function, they're called arguments. So that's just something to keep in mind. Does that answer your question?
Yeah, thank you. Well, if you say inputs, is that kind of like, that's just kind of like when people say sometimes like passing in my input or something like that?
Yeah,
Is
so that would
also
refer to an argument. I tend to use inputs and arguments as interchangeably.
okay.
I do sometimes get a little loose there,
Yeah.
but you know, if you're going to be truly accurate, input and argument are the same thing. They're the values you're passing into the function when you execute it.
Thank you.
Yep. All right, so back to my filter. So my filter, its parameters are some arbitrary array and some rule. Okay, so what we're going to assume, again, we need to assume that our rule takes a single number as an argument, and we know that it's going to return a true or a false. And if it's false, we don't want to keep that number in the array. If it's true, we do. That's it. Those are the only assumptions we're making. So that allows our logic to actually be really, really simple. So what we're going to do is we're going to make an output array, this guy. Okay, we're going to then loop through that array. And then here, we're simply going to say if it passes the tests. So if current number in the array passes, then add it to the output. Otherwise, do nothing. That's it. That's the logic. What's cool about this pattern, as we'll see in a second, is the fact that it doesn't care why the number passes or not. It just cares whether it passes. And that's kind of the power of this pattern, is that we get to really spread out our logic or separate our logic. Okay, so what we're doing here is we're saying if the current number passes, then add it to the output. So that's going to be simple. We're just going to say if the particular number that we're in right now passes the test, so we're going to pass it into our rule. Okay, so we're going to execute our rule function. And if that's true, okay, if that's true, then we're going to go ahead and push it into our number. And in fact, just to make it easier to read, I'm going to call it current number. Yeah, current number is equal to array I. And then there we go. Okay, so we're snagging whatever element we're in. And if passing that rule if passes is true, then we're going to put it into the array. And at the end of it, we're going to return the output. Okay, this is the key right here, is that we're assuming this function takes a number and gives us a Boolean value. Does anybody have any questions about this logic before we actually execute this, or before we go to the next step? Cool. Okay, so now our filter function's done, but we've got to actually use it. Okay, so we want to get only the odd numbers. So let's break this down into a couple of steps. So we know how to get an odd number. So let's start with, okay, I want to ask a question, given a number, is it odd? We're going to write a function that's its only job. Given a number, yes or no, is it odd? Okay, so it'll take x as a number, and we're going to ask the question, is if I mod, or sorry, if I do x mod 2, if that number is 0, you know, because for any even number divided by 2 isn't going to have a remainder. So therefore, it's always going to be 0. Okay, so if so to know whether something's odd is to ask, hey, if I divide that number by 2, does it have a remainder that's greater than 0? I don't care what value it is, as long as it's greater than 0. Okay. So, okay, cool. So let's just verify that this works. So we're going to do, we're just going to do a little test here. So log is odd. Okay, we'll do 2, and then let's do 3. Technically 0 is not an odd number, but we won't worry about that for right now. So we've got 2 and we got 3. So when I run this function, when I run this program, I should see false and then true. Let's make sure that my logic's right. 2 is not false, or sorry, 2 is not odd. Beautiful. 3 is odd. True. Okay, great. We know that this little function's working. Okay, now what we're going to do is we want to make sure that if we have some collection of numbers, an array of numbers, we want to ask the question, or what we want to do is we want to get a new array that only contains odd numbers. Okay, so the way to do that is we're going to employ our filter function. Our filter function takes an array of numbers, which we've already defined up here. And in fact, let's bring this down here so it's easier to see. Okay, we're going to get rid of this. So we have all our ingredients. We have the array of numbers, and then we have a function which asks the question, is this number odd? When we combine those together and pass them into our filter method, we should now see 1, 3, 5, 7, 9. Let's see if that worked. Hey, check it out, it worked. So when you see the array filter method, this is more or less what it's doing. It's a little more complicated than that because there's a few other things they let you do with it, but that's the basic idea. And this pattern's really powerful because this allows me to separate out the logic of filtering from the actual filter rule itself. Okay. Let's look at the map method. But before we do that, I want to make sure that there's no questions. Does anyone have any questions? Beautiful. All right. Okay, we're going to look at how map works. Map is actually even simpler than this, believe it or not. Okay, so in fact, I'm just going to create another file over here. Okay, so map is ridiculously simple. And if you remember what dot map is, all it is a transformation. map just takes an array and creates a new array containing elements which have been transformed from the original array. Okay, that just means that I take an array of things, let's say numbers, and I create a new array of whatever rule or whatever transformation rule I've decided I care about. Okay, so we're going to do a simple arbitrary example. So let's think about this one's a little more abstract than the filter, but the logic is actually simpler. So let's think backwards. What are some? Can anyone think of some useful things for .map? Like, what are some useful applications of a .map?
Would you be taking an array and then pulling out items to create like an object?
Could you expand on that?
Well, if you had like an array with like a name and then a number, it just, and then, yeah, I don't know.
Would you use it if you want to make a change to each item in an array?
Yeah, if you want to make some sort of change. Yeah, that's a good way to put it. So, exactly. So I don't know if any of you have used React. Well, I know some of you have used React. If some of you haven't, that's all right. But there's this concept in React of taking an array containing data and transforming it into a visual list on a page. Map is really useful for that because you can take raw data, just an array of raw data, let's say users or books or whatever. You can take that raw data, port it through a .map method, and then return actual UI elements that the browser can interpret as, you know, something to display. That's like the most common thing in web development is what map is used for. But it's also useful for just like doing any kind of transformation that you want. So we're going to use it as a transformation we're going to assume that we have an array of strings and we're going to uppercase it. I know it's trivial, but it demonstrates the concept. So what we're going to do is we're going to take a map. We're going to have our map method, which again, we have to make a few assumptions here. We know that it has to be an array, and we know that there's some transform rule. Okay, the transform rule is just a function which takes a single argument, one element from this array, and does something to it. And that's it. It just takes a value and then produces a different value based on what that first one is. We could, in math, you could imagine the transform rule being like to multiply it by 2. Take a number, multiply it by 2. Okay, cool. That could be useful. In this case, we're just going to take some string and we're going to uppercase it. That's it. But what's cool about this is that we are now abstracting away the two pieces of logic here. We're taking out the logic of actually producing the array of transformed values and the rule for transforming itself. This allows us to have an infinite number of possibilities as opposed to having to write like an uppercase map or a multiply by 2 map. We don't have to write like 50 different map functions. We can write one single map function and then just provide whatever rules we want depending on the situation we're in. Okay, so what we're going to do here is we're going to again, do exactly what we did before. We know that we have some array, okay? And then we know that for each item in the array, we're going to call the transform rule and put the new value into the output. That's it. That's it. So in this case, it's even simpler.
Wait, so do you choose the array, or do you choose each one for each item, or does it just do all of them at once?
We're going to do all of them. We're going to loop through just like we did with the filter. We're going to loop through and simply push the new value into our output. Just like with filter, where in this case, we actually only put it into the output if it passed, if this rule came out to be true. In this case, we're not discriminating, right? We're just saying, hey, produce a new output or produce a new array that just has the same amount of items as the original array. It just is now going to contain items that have gone through that transformation process. That's it. Does that make sense? All right, so we're looping through our array. We have our current item. We don't know what this is. We don't care what it is. This function is very abstract. It doesn't know or care what type of item this is. So we're going to grab our item from the array and we're going to get it transformed. We're going to say, okay, transform rule our current item. Okay, we're going to transform our current item to get this new value, whatever it is. And then we're simply going to add it to our output. Okay, once we're done, once our loop is over, we're simply going to return the output. So to see how this works, we're now going to, let's make some arbitrary array. We'll call these strings. Last time I did numbers. Okay, we'll do A, B, C, D, and we'll just go up to F. Cool, beautiful. Okay, now what we have to do is, if we're going to use our map function, we have to pass it our transform rule. Okay, so we're going to, again, break this down into separate steps. If we're going to call our map function, we know that we have to pass it an array, but then we also have to pass it a rule. Okay, so we're going to make a rule called uppercase. Our transform rule is going to take a string, take some string, and we're going to uppercase it. Luckily, all strings have this method. So our map function is going to simply take that value. So now we should see capital A, B, C, D, E, F, etc. See if it works. Boom, there it is. I know that's kind of fast. Does anybody have any questions? All right, cool. Take that as it makes sense. So we're going to do a couple more examples. But what's cool about this pattern is that all we're doing is worrying about inputs and outputs, okay? Our map function takes an array and some function, some arbitrary function, and it loops through that array, calls that function for each item on it, pushes it into a new array, and then gives us the new array. Okay, it's just input output. There's no fancy inheritance here. There's no hierarchy of classes or anything. We're literally just dealing with inputs, outputs. That's one of the beautiful simplicities of functional programming, which I like. But this can get incredibly abstract. We can start doing some very, very cool stuff with what are called closures. And we can do some other very, very, very interesting things. And that's what we're going to talk about next. So we're gonna talk about this fancy thing called a, there's two very, very important kind of, this is kind of the very first, this is kind of the very first step into functional programming, is this idea of a closure. And we've talked about this in past code talks, but we're gonna step into it again because it's to me this is really fun, really interesting. So okay, we're gonna think about this. Suppose I want to add two numbers together. What's the simplest way to do that?
JavaScript has built-in functions for that, right? So you just add them together. So you just use plus, right?
Yep, I can use plus. But what if I want to? I want to write a function that allows me to add two numbers together. How might I do that?
Oh, sorry. Yeah. So you do your function, and then in the you probably name num1 and num2 as what you'd pass into that function, and then you can have your logic there that would add num1 and num2.
Exactly. Cool. All right. Pretty simple. Right, so now if I do add 1 and 2, that's going to give me 3, right?
Yes, in theory. I feel like that's a trick question.
Yes. So this works. I can guarantee you. But let's just indulge this. There's a reason I call this pipe, which we'll get to in a second. Okay, cool. So there's 3. Okay, fine. Okay, however, there is a much more interesting way of doing this. We're actually going to do this in another way. Instead of defining our add function as a function that takes x and y, what we're actually going to do is we're going to define a function that returns another function. So bear with me for a sec. So our add function, just in JavaScript, we already know that it can take a function as an argument. We already saw that. We already saw that in map, right? Here's taking a function as a parameter in map, right? And we're passing it our uppercase function as an argument here. And we did the same in our filter, right? It can take an argument, or it can take a function as a parameter. Okay, there's no mystery there. But by the same logic, if we can take a function as a parameter, well, we can also provide one as an output. Because again, functions are just values. We can pass them around just like anything else. So what we're going to do here is we're going to take a function that takes a single number, and we're going to return a function which also takes one other number. And that function will add them together. So this is going to look kind of weird. Okay. anyone looking at that being like, what the hell is that?
Yeah, that's crazy because you've got like the arrows, but not the parentheses indicating that it's functional.
Right. So we're going to, just for the sake of reading this a little easier, I'm gonna turn this into I'm gonna not use the implicit returns that ES6 does. Okay, so just so this looks a little more natural. Okay. So my add function is a function that takes x as a parameter, and then it returns this function. And what's interesting about this function is that it has access to that original x number. Okay, so this is cool. So instead of doing something like this, 2 and 5, what I'm actually doing now is this. Okay, let's see if it works. Yep, look at that, 2 and 5, that's 7.
I'm making noises of confusion and awe, but my mic is off because I didn't think anybody would care to hear that, but it is really weird.
Yes, so why is that?
I saw this a bunch and I like didn't understand it, but having it broken down is there a benefit to doing it this way? There must be.
So for adding, I'm not sure if there's a good argument for this. But for other types
of, there's a reason you're showing us this.
Yeah, so this particular example, you could argue that this is maybe a little overkill for just adding numbers together. However, this pattern is really, really awesome because it lets me kind of configure my return function in really cool ways. So for example, just so you can kind of see where this comes from, I'm going to write this a different way. Okay, I'm going to say const add to 5. Okay. Okay, quick question. What value is that? What data type is that?
True.
Nope.
Nope.
If I were to console log this.
Function.
Yep, you're right. It's a function. Check it out. It's a function. So what I've done effectively is separate out the thing I'm adding to I'm separating out the number 5 and the thing that I'm adding to 5. I could say add to 6. And this becomes a function which lets me add 6 to anything. Okay. So let's just start with 5 simply. And now what we're going to do is we're going to say, okay, add to 5. I'm going to pass some number. We'll do, let's do 100. Okay, so now, hopefully, I should now see 105. There it is, right there. Pretty cool.
How is it that you can just put one argument for add? Wait, can you try to explain that?
Sorry, could you repeat that one time?
How is it that you're only adding? So is the 5? I'm just trying to put it together. Do you think you could just like talk through that?
Yeah, are you wondering about there's no y in that and how it can?
Yeah, like how are you using just like a portion of the add function? Or what portion of the add function are you using?
So that's a great question. So let's look at this first line, add to 5. Okay, when I call this function add 5, let's ignore this block of code and let's just look at the fact that this function only takes one argument, or one parameter, I should say. Okay, so I know that this function takes some number x as an argument. Okay, cool. Okay, well, the question is, what does this function return?
It returns that x plus, I guess, something else.
What is this?
The y.
what is this?
It returns a function.
It returns a function.
That you're adding x, which is 5 in this case, plus something else.
Yes, exactly. So
neato.
Yeah, it's very cool. So my first call gives me a function which kind of lets me hold on to that original number, but then I get access to this function. Okay, and that's what this is. So then I can call this function and add whatever numbers I want to my original number.
I get it. I
just yeah, I mean it's kind of crazy, but it's a pattern that you can use. So all right, we're gonna abstract this even more. Okay, we're gonna what we're gonna do is there's a common how do I put this? So we're going to kind of exploit this pattern even more. And in functional programming, there's kind of two functions that are kind of just, they're just so common that they've kind of become the bread and butter. And they're called pipe and compose. Okay, so there's pipe and there's compose. They're very similar, but they do opposite things. Okay, so when you pipe something, that means that you are taking a series of values and pushing them one by one through a process. Okay, when you compose, you're doing the opposite, and we'll talk a little bit more about that in a second. It'll make a little more sense once we talk about pipe. Okay, all right. So what we're going to do is when we call this pipe method, what we're really doing is we're expecting we're taking a value and we're going to pass it through some series of commands. And those commands are completely determined by whoever is using the pipe function. It's kind of like map and filter, where the map function itself doesn't know or care what items are being filtered or what items are being transformed. Its job is to simply execute those functions and then provide the array containing the outputs. But it's not responsible for determining why something should be filtered out or not. Because we could have, for example, to go back to our filter example, I could just as easily define a function that filters out even numbers. You know, this is entirely arbitrary. I just as easily could have changed this to less or equals 0, and then now all of a sudden my function's called is even, effectively. Okay, so our pipe method takes some value, and what it does is it's going to return a function, just like in our other example, just like in our our little adder example. Okay, and this function is going to take an arbitrary number of arguments. It doesn't matter what they are. And what's going to happen is for each argument, we're then going to take the value and we're going to output it, or sorry, we're going to take that value and we're going to use it as the input to the next function. And then that function is going to take that argument, or is going to take that output and use it as its input. And it's just going to, it's kind of like a centipede. It's just going to process that value over and over again until you get to the end. So we already know what our first value is. It's X. Okay, so our initial value is X, whatever that may be. Okay, now what we're going to do is we're going to set our initial value. We're going to reset it to whatever our next process is. So our next process is whatever function we are on in this array. It's an array of functions. So we're going to say current process is equal to, or sorry, current process is equal to args I. Okay, so now we're going to reset our value to be current process with whatever that value is. And in fact, I'm not sure initial value is actually the best name for this. I'm going to call this, I'm just going to call this output. That way it's very clear that this, whatever we're getting at the end of this is in fact the output. Okay, so to recap, pipe is a function which takes some value. I don't know what this is. It doesn't matter what it is. It's not the job of pipe to care what it is. The job of pipe is to simply take some arbitrary value and port it through some series of arbitrary processes that whoever needs to use this function is going to use or define. So we start with whatever our initial value was, X. We're going to loop through our arguments, our processes, and we're going to simply set the new value to whatever the output of our current process is. And we're just going to keep repeating that over and over again. And we'll kind of see how this pans out.
So is it really just kind of like a big machine that's just, you know, going through this functional process of processing whatever it needs to process through a series of, you know, it sounds like a machine.
Yeah. Yeah. It's just a machine. Easier. That's a good way to put it. It's just a machine. So this is what we're going to do. We're going to say, okay, const process, or actually, no, I'm going to use your word. I'm going to call it machine because this is kind of useful. Okay, so we're going to say pipe, and then let's pass in a number. Okay, it's just going to be 1. Okay, so our machine, when we call our machine, we are going to pass it, just like what this says, a bunch of different functions. Okay, so, and it's going to happen in order. Okay, so our first function, let's say we want to multiply this by 10. Okay, again, this is totally arbitrary. Okay, I'm gonna have a function that takes some number and multiplies it by 10. Okay, cool. Okay, now I'm gonna write another function that adds 2. And again, this is going to be x plus 2. Okay, and we'll do one more. And then this one will be subtracts 1. Okay. So we're going to put our value, our machine that handles our value 1, and we're simply going to say, I want you to multiply by 10, and then adds 2, and then subtracts 1. Okay, what do you expect this value to be? Yeah, so hopefully, if I did this right, it should be 11. Hey. I don't know about you guys, but that's pretty awesome. I think that that is really cool.
Yeah, that's one of the coolest things I've seen, actually.
Yes, I'm so glad. I'm so glad you think so. Because this pattern is really common. And if you can demonstrate these kinds of things in like a tech interview, it shows that you have a pretty good handle on abstract thinking and just some more advanced programming techniques. This is a really good thing to know. This is just such a cool pattern because it's a really helpful way of abstracting away various things. And what's cool about this is that if I, for whatever reason, decide that I no longer want to subtract 1 and I want to subtract 2, well, all I do is simply replace that function with a different function. And it's basically like I can just fine tune my machine to do whatever I want it to do. Does that make sense?
Mm-hmm.
Cool.
So did you name this pipe, or is that is this pipe function like a saved thing?
Oh no, I made all this up. This is just a pattern that you can exploit just by virtue of the way that JavaScript lets you pass around functions as values.
Oh, I like the name, I think. Fitting.
Yeah. Mm-hmm. But but pipe has become kind of the convention. If you ever look at, I'm going to show you guys some libraries to play around with that like takes these things to kind of to a whole other level. A lot of programmers have already there's basically a whole libraries that have really cool tools like these already built in, so you don't have to like write them all from scratch. But I think it's important to understand pipe and compose, because everything is kind of based on this idea, and they're written in different ways, but the concept is there. So okay, let's look at compose. So compose is just the exact opposite of pipe. Okay, so compose is you take this series of processes, but you put them in reverse. Okay, so you start with your number. Okay, so compose is X. And then you're going to process them backwards. So it's actually almost identical to this. Okay, so instead of going left to right, we're going instead of going left to right, we're going right to left. Okay, so we know that this function is going to take some series of arguments, some processes, some arbitrary functions, whatever they may be. We're going to loop through them. But in this case, instead of starting at 0, we're going to start at args length -1. We're going to start at the end of the array. Okay, and then we're going to just make sure that I is greater than -1. Okay, we're gonna go from the end to the beginning. And we're gonna subtract each time. But then the logic is identical. We're going to say, okay, here's our output, which is going to be X to begin with. And we're then just going to say output is equal to whatever our current process is, or whatever the output of our current process is. So we're going to say current process output. And then at the end, we're going to return our output. Cool. So what we're going to do is we're going to take this exact same thing. So I'm going to take our list there and put it down here. And instead of calling, oh, oops, sorry. Let me, I'm going to take all of this, comment that out. Okay, let's start again. So our machine is now a compose machine. We're composing. Okay, but we're going to use the same functions. We're going to multiply by 10. We're going to add by 2. We're going to subtract 1. But now, what's our value going to be? If we start with 1, what's our value going to be?
$20.
Yeah, exactly. Because we start with 1, we subtract 1, which takes us to 0. We're going to add 2, which is 2 times 10 is 20. So if we did this right, boom, 20.
So what's a real life reason to work in reverse like that?
So you can, it just kind of depends. I haven't, there's nothing that you can't do with compose that you can do with pipe. So like I haven't really ever had a reason to do a pipe instead of a compose. That's a great question, because they're logically equivalent. So it kind of just depends on, like, I can't really think of a use case where you'd use one besides the other. Pipe to me makes more sense because it's just sequential. But it's a thing. So I don't know if that's a satisfying answer, but it's a thing.
Good to know.
Yeah. But let's see here. So this is like the tip of the iceberg in terms of what you can do with this concept of functional programming. So there are 2 libraries that I'm going to advise you guys check out and just play around with. They're 2 of my favorite libraries ever. So one is called, Lodash, which I don't know if maybe you've already heard of. It's called Lodash, and it's a functional programming library that has so many cool little bits of functionality. So let's look at the documentation. Okay, so the reason why it's called Lodash is because it's common to import it as a Lodash because it's just a bunch of utilities, right? So there's some of these. Let me find one that's actually really cool. Find is really cool. Okay, find. It says, okay, given an array and a function, give me all the things that match that rule, whatever it may be. there's includes. This asks the question, hey, does this array include this value? Cool. It's like yes or no. Reduce is my favorite function of all time. I'm kind of a nerd for saying that, but that's all right. But yeah, reduce is the coolest function ever, just straight up. I'll fight anyone who thinks that that's not the case. And anyway, so there's a bunch of cool stuff in here. So I highly recommend playing around with that. Join's another cool one. Flatten. Anyways, play around with that. It's cool. But Lodash is really cool, but Lodash doesn't have anything compared to RxJS, this library. And this is actually what Angular is based on a lot of. And oh my God, it's dope. It uses this concept of what's called an observable. So if you guys in your day-to-day life, if there are two libraries to really get familiar with, it's these two. There's a lot of other cool libraries out there that are, these are the two best utility libraries that you could possibly master. If you can really get a feel for these, then you're going to be like a Jedi of programming. There's just so many cool stuff in here. I'm not going to spend too much time with RxJS, but it's just so cool. So I'll let you guys read the documentation, but basically it's just a event listening library. So it's a really, really cool utility library for customizing events, which I know sounds really abstract and maybe not that exciting, but oh my God, it's so cool. So an observable in RxJS is this it's this idea of it's a value that you can subscribe to such that when it changes or when some event goes off, you can then do something with it. It's very similar to like in JavaScript, just in plain old JavaScript, when you're listening for like click events or scroll events or something, you can do this whole document add event listener, and then it says, hey, when there's a click, do this thing. And in RxJS, the pattern is very similar. We're saying, hey, when this thing happens, subscribe to it so that this particular action occurs when that event happens. But it's really cool because this can go both ways. You can trigger your own events very easily. And then here's our good friend pipe. What's amazing about this whole pattern is that everything can get this thing called an observable is just this object that just has a certain set of properties that allows it to get passed through infinitely many processes in such a way that it's very easy to specify how that process works. So in this case, for example, you have some click event that happens, and then we can pipe that event through another series of processes. In this case, scan, which means, hey, let's check how many times this click event happens. So we're going to take this count, add 1 to it, and then we're going to subscribe to this event that gets generated from it so that whenever that count happens, whenever that count goes up, we're going to do something with it. And look how streamlined that logic is. I just love that. That's just fantastic. Like that is art right there. That's like the Mona Lisa of coding. So I highly recommend playing around with RxJS. It's amazing. It's really cool. And if any of you ever have any like questions or whatever about
once that library is downloaded, you can just instantly. So once that library is downloaded, you could just instantly use those different methods and functions.
Yep. That's so like cool. in my projects, these are two libraries that I have. They're basically the first things I download. But what I would recommend is, while they're very, very cool, I would recommend trying to figure out how it works. Like, I'm all about using libraries. My philosophy is, don't reinvent the wheel, but don't use things that you don't understand. So if you're not sure how an observable works, don't just use them because they're easy to use. Just take the time to understand them first. When I first used this library, I was very excited because it just seemed to magically do all these things that I wanted, but I was just like, man, I got to figure out how this works. So I wrote my own observables. I figured out how to write my own like mini RxJS library, so that when I'm now using it, I understand how it works. So when there's bugs, when there's problems, I can use my understanding of how it works to debug, because it's very hard to debug something that you don't conceptually understand. So that is my advice. Use the tools that are available, but make sure that you understand those tools on a basic level. So my challenge to you guys, your homework, is try to write your own reduce function. So you've probably seen an array. So we'll do 1, 2, 3, 4, 5. Okay. So reduce is a method on arrays. Okay. Your homework is to figure out, first of all, what reduce is, if you don't already, and write your own reduce function, the way that I did pipe and the way that I did filter and map. And if you're not sure where to start, feel free to contact me. I'd be happy to help. But doing this kind of stuff will make you a much better programmer, I guarantee you. So with that, I'll open it up to questions.
Hey, Ben, I just had a question. Like, do you use functional programming more or object-oriented programming as a software engineer in your day-to-day life?
I use both very often in my day-to-day life. Yeah. You can't really escape either one.
Okay.
Yeah, like because it also depends on, like, for example, in Angular, which I use at work, we're on like what, version 10 now, I think. There are a lot of object-oriented concepts there. But what's really cool about Angular is that despite the fact that the component tree is very much object-oriented, the services and utilities are all functional programming based. Like, the bread and butter of like almost all of the functionalities within Angular are all based on RxJS. In fact, when you download like the Angular, what's it called? Like the Angular bootstrapping library. It's kind of like Create React App. There's an Angular equivalent. You can just basically have download your own like little starter sandbox Angular environment. It comes with RxJS already installed. That's how important this library is for Angular. So it's kind of, to answer your question, it's both very often.
Thank you.
Yeah. Anybody else? Nobody has any questions?
Hey, I have a question, yes. But
go ahead.
Can I wait till everyone leaves the call? Because I think it's really elementary.
Sure.
Okay.
No problem.
And that wasn't asking everyone to leave, but I'm.
It's like, all right, everyone get out. Just kidding. Anybody
Just
else?
ask it. I dare you.
Greg, you might.
Don't be afraid. Don't be afraid of asking. Like, I've been doing this for 4 years, and I ask questions to my boss sometimes that I think are like really basic, and it's fine. Like, whatever. There's a lot of things I don't know still, so it's okay to not know something.
Yeah, I'm very beginner still too, so go for it.
So, Ronald, if you want to hear my dumb question, that's fine. So I'm coming from like a really not technical upbringing background. I'm totally geeking out on all this, and I really appreciate the way that I don't know, I could see myself in the future having quirky things like favorite functions or favorite methods and things like that. So
yeah,
I feel like
very nerdy.
Yeah, I like the ability to appreciate the world you're in for like, you know, see the beauty in something that might not otherwise be beautiful to other people. So
right.
Yeah, I like the art.
I really appreciate I really appreciate your I don't know, appreciation for what you do.
Cool. Well, I'm glad that you appreciate it, because like, not everybody can appreciate this. Like, you know, if I can't talk about the reduced method to like my friends.
You'll be able to talk about it with me,
but I can talk about it with you guys. I actually know
reduce all right. Yeah. No. I really, really find value in that style of thinking.
Awesome.
So my question is, because I'm so new and I'm actually almost done with level 3. So I've been coding for a minute, and I feel like I've got a good handle on coding. I mean, it's for where I'm at and doing the work.
Mm-hmm.
A lot of what I don't understand is the jargon around the tech scene and, you know, people throwing around something like a library or whatever.
Okay.
I feel like I'm close to it, but I still don't really understand what a library is.
Okay. That's a fantastic question.
Yeah, there's a lot of things simultaneously that I'm trying to understand, like the fundamentals of, and I think it seemed like a good opportunity. You seemed like something that might be able to maybe explain to me in a way I haven't heard yet.
Yeah, I'd be happy to. And by the way, that is not a dumb question.
So those libraries that you're importing, so basically those are just a whole bunch of files on their server, right? On like JSX.
Yeah, essentially. So
and I barely know what a server is, so that's kind of where I'm at.
This is how I would think about it. So let's pretend for a minute that the internet doesn't exist. Okay, there's no internet, which I don't know what the world would do if there was suddenly no internet. So we're going to pretend that there's no more internet. Okay, so what I'm going to do is let me just open a new project here, just so we can kind of mimic this idea of, I don't know, I'm alone in the world.
Let's set it up. It's a post-apocalyptic.
Yes, it's a post-apocalyptic.
The dust is settling, and you're emerging from your bunker. Go.
Exactly. Exactly. Oh, why isn't this? Oh, duh.
That's so good.
Okay. There we go. All right. Save all. Okay, so here's my application. Okay, I'm going to call it app.js. Okay, so when you're writing a program, you're obviously just writing code that does something useful, right? So whether it's a application that lets you buy and sell Bitcoin, or, you know, it's your portfolio site, whatever, you know, at the end of the day, a program is just, or an application is just a program that does something, right? So now if I were to make an application, I'm gonna want to organize it in some way. So that means that I'm going to want to break it down into different parts, right? So, and those parts are kind of just responsible for doing just very specific things. Let's say, for the sake of argument, that I'm writing I'm making a website that teaches math to little kids. Okay, so this might be a fairly complicated web application. Okay, but to simplify things, we can understand on a conceptual level that there's going to be a bunch of code that's relevant to displaying stuff on the screen, right? But then there's also going to be a lot of logic that only deals with purely doing mathematical calculations, right? So that means that if I'm a good programmer, then I'm going to just have a toolbox full of my mathematical things. Things that will, yeah, all my operations, okay? So for example, suppose I have, here's my website, index.html. And we're gonna have some, I don't know, this is I'm totally making this up, but we're gonna learn how to add numbers together. So adding 1 plus 1 equals 2. Okay, great. Kids, let's all gather around and learn math. Awesome. Let me, and we'll open this with live server. Okay, we'll have, okay, sweet, awesome. Okay, so here's my sweet little website that teaches kids math. So in this case, I've kind of got this problem where I've got this issue where I'm kind of hard coding text that's doing my math. That's kind of like, I'm trying to do the math, but also display it at the same time. Now, that's fine, but this is kind of a pain to have to, write out every time, right? Like to do the actual calculation itself over and over and over again is like kind of a pain. What I want to do is to just have a set of functions that will just do the math for me. So I don't have to worry about it, right? Because like, what if I'm trying to demonstrate, okay, how do we do 578 plus 1,754? Okay, well now I have to sit there and be like, when really I just want to add them together. I don't really care, right? So, this is how, if I were to, if I were writing my program, I would do something like this. I would have a separate file and I'd call this my math file. Okay, so my math file, its only job is to just its only job is to just be a place where I can grab functions that do the heavy lifting for me. It's just like grabbing a hammer out of my toolbox or a screwdriver or whatever. It lets me do the job just way easier than having to like, do it in my head.
So why would this make a program faster?
Say what?
Why would pulling those functions and operations from your math file make your program faster than just having I'm not
talking about speed right now. There's another reason why, which I'll get to after.
Shorter code, I guess.
For now, cleaner. Yeah. For now, it's just the fact that this code is much easier to update and manage, right? So if I have all of my math places in one spot, so here's my math file, I can now provide functions that will take, so for example, add. Check it out. I now have a function called add that I've defined in one place that I can now use in other places. So I'm going to now say, okay, math is equal to require math. Okay, so if I needed to, I can say math.add 1 and 2. Okay, what I'm doing in my application, I'm saying, hey, math box or math library, I want to use you for a sec. I need your stuff. So you import it into your application and then you just simply use it. So in this case, my math library is really just a file that exports functions. So when we're talking about—
I've essentially been making like a lot of libraries.
Oh, hell yeah. Definitely. So without maybe even knowing it. And in fact, this is kind of the proper way to structure your code. Like, so you've probably made some programs by now that have like several files where you're exporting from them, and then you're just kind of piecing them together like Legos.
That's like literally where I'm at. So.
Yeah, and so a library from a conceptual level is just this idea of a file basically that just has functions that you can grab and reuse in other places. So now whether those libraries are something that you created, because maybe you have some very specific thing that you need to do, so you are going to write your own library just for convenience, because a library is very easy to update and very easy to test because everything lives in one place. And if you need to make a change, or if there's a problem, you know exactly where to go to fix it. You don't have to like, it's not duplicated everywhere. You don't have to like find where that particular logic was. It's like, oh no, it's right here. I just go here and I fix it here and no problem. So now suppose now there's this math library, which is fine, but let's say you're teaching like calculus or some higher level math that you don't want to write all the logic for doing like derivatives and stuff. There's probably a math library, there is, for doing these kinds of things. So you would download it, like you'd import it. It's just, you didn't write this file, someone else did. So you just grab that file that someone else wrote and you use it in your application.
You essentially like use their functions or methods or whatever they've written, and then you put your own parameters.
Yeah, you use it. Yeah, exactly. You import their functions and then you execute those functions with the values that you care about. And this pattern is universal. Like, this is properly written code is going to exploit this kind of pattern a ton, because the more reusability your code has, the easier it is to maintain, the easier it is to read, the easier it is to manage, and easier it is to update. So yeah, when you're—
And what is the module.exports? Is that I haven't seen that.
I was just gonna ask that too.
Yeah, so that's a great question. So this is just something that's very specific to Node itself. Now you've probably been building like I forget what level 3 is.
So I'm doing like it started out, or at some point I was doing like state props classes.
Okay, yeah. So you're doing React.
And then now it's more, yeah. Oh yeah, for sure. It's like the basic React.
Yeah. So you've been doing stuff like this.
Yeah. Yeah.
Same thing. It's just updated syntax. Okay. In fact, I'm not sure if I think if I were to do math from, I think my version of Node isn't gonna like this. Let me just double check. Yeah, so I'm using like Node doesn't really respect this syntax yet. That's why there's like Webpack and all this other fancy stuff, which lets you write stuff this way, but then it like, there's just an extra compiling step that's happening. But to answer your question,
I've seen
module
Webpack,
exports is the exact same as import. It's just older syntax for accomplishing the same thing. Oh, you're muted.
I muted myself, so sorry for all the noise that you did hear.
Oh no, you're good.
I've seen the Webpack Word or whatever when I've been uploading the React stuff.
Cool.
So that makes sense. Thank you for clearing that up.
Yeah, no problem.
And I won't worry about it.
Awesome. Yeah.
Not yet anyway.
And don't worry about asking stupid questions. That was a fantastic question.
All right, cool. Well,
yeah. So anybody else?
Thank you again. No, this was great. Thank you so much.
Yeah, this is very helpful.
Yeah, and feel free to reach out on Slack or wherever if you need help figuring out how to write your own custom reduce function. It's not as hard as you might think, just so you know, just as a hint.
Yeah, any tips for like, so you said before you did not come from a coding background. Can I just plug you for like, how did you get to the place where you started asking yourself the right questions? I find it often that I feel really stuck. The instructor asks me one thing and I'm like, oh, duh. And they're like, why? You knew the answer. You knew how to do that. But I don't seem to ask myself the right things. Is that something that just clicks over time and experience, or is there some sort of way to think about it or approach something in a different way than I already am? I get lost in a lot of the jargon. I don't know.
So,
one thing I do is I'll just write a code, like a program over and over again, just to almost memorize. It's not necessarily like the words, but just the form, you know, and then all of a sudden your brain starts to recognize the pattern. I don't know, it's just a kind of a way that I've been learning.
Yeah, sure. Like, I think I know what you're saying. In the beginning, when I was learning the React, I really wanted to be comfortable and confident with like props. And I would several times like take something and change it from, you know, whatever function to a class-based function and like, you know, just like that kind of stuff. But I'm talking about more like the problem solving aspect of like the question that was asked or the assignment at hand.
So for me, yeah, so I didn't come from a tech background necessarily. I was always a nerd though, you know, I will say that. That never changed, but
well, we're all kind of nerds, right?
Yeah. I mean, to me, it's a compliment when someone calls me nerd. I'm like, damn right. So I basically, for me, so first of all, I've been doing this for like 4 years. I started in 2000, actually, yeah. So I started in like 2016 is when I started like teaching myself. I went to a boot camp in 2017, and then I taught there afterwards, like first as a TA, and then I became like a full-time instructor for 2 years. My background is in philosophy. That's what my degree is in. So I studied logic. So I already kind of had a logical brain, I guess, but like what I did is I was just very, very curious. And I think curiosity is basically the engine of understanding. So you say that, you know, you're trying to understand like the jargon, you're trying to get more comfortable with a lot of these concepts. That fact alone means that you're curious. And so whenever you find yourself like being like, what is that jargon or whatever, that's a sign to just go explore it. What I've found is that as every time that there's some new thing or whatever, that becomes my new rabbit hole. I fall down the rabbit hole, and then all of a sudden I'll come out in a place that's familiar, and it'll connect me with some other rabbit hole that I've been down before. And all of a sudden, as I'm going down these rabbit holes, I actually find that my network of rabbit holes are all connecting over time. It's just taken time. It's really just a matter of curiosity and time. That's it.
So funny. That's just like really how life works. So for me.
Yeah, it really is. So like, you know, I've found when I was, you know, I taught this for a couple of years, and students would get really impatient. I would find, and I was impatient too when I was a student. Like I was like, why don't I know this already? And it's like, dude, you've been learning a new language for like 2 months. Relax. So it's a new language. It's brand new. It's very hard. It's constantly changing, and it's very complex. So that's why it may seem like you're not getting it, or maybe that you feel like a little bit mystified by certain things. Like it's normal, like especially you're on what, level 3, you're still on like the tip of the iceberg, and it's just a matter of time and curiosity. So use those opportunities when you're not sure about something to just, that's your trigger for, oh, I'm going to be curious about this. I'm just going to go look into it more, because you'll find that it's a very geometric thing, this world of coding. You're going to go into a rabbit hole, and it's going to seem dark and scary and weird. And then all of a sudden you're going to see how it connects with something that you already know. And over time, those connections are going to become stronger and stronger and stronger, to the point where the next time you hit some rabbit hole, your past experience with all these other rabbit holes are going to inform how to approach that new rabbit hole. And it's like a snowball. It's just over time, it becomes much, your past familiarity will then reinforce your next adventure.
Yeah, I think a lot of things are still in hindsight, you know, or in retrospect, or however you want to put it. It's like, you know, once I get through it, it's like, oh, of course, you know, of course, I totally get this. But it's just really always after the matter. So, or a lot of times, you know.
Yep.
So I feel like there's hope in that, because I'm not left with like, well, it's done, but how? It's like, oh, totally. I just wish I could get to that without being prompted by someone else, I guess.
Yeah.
I don't know. Everything that you just said gave me so much, like, it gave me a lot. So I appreciate you lingering here and discussing this.
Yeah, this is like
kind
my
of
favorite
leading
thing.
a little into my insecurities.
Yeah, absolutely. Like I love teaching. Like that's like coding's like my job, and I love coding, but like teaching is like my passion. Like I love teaching people this stuff because it's just so cool to me. So like I would, and maybe one other thing too is try being a mentor to someone else. I've found that my experience teaching was probably the most that expedited my understanding faster than anything else, is that someone would just come ask me a question that I didn't know, and I felt responsible for helping them know it, so I would have to go understand it myself.
Yeah, no, I've definitely been suggested to try to find a mentor. The only problem is I feel like it would be some like rigorous
no, be a mentor.
No, like interview process for me, because I feel like I really have to connect on a certain level. I don't know. Well, if you're open to mentoring still, I'm sure you're busy, but
I would be happy to. I mean, I don't have like I just kind of do this for fun in my spare time. So I'd be happy to just like reach out to me in Slack and we could figure something out.
Cool. I really appreciate this. Thank you.
Yeah, of course.
Awesome. Yeah, because I'm just about to get into using Git with another person and branches and all sorts of stuff.
So scary.
It's
just really over my head, but I get the passing around of files and stuff. I see what's happening. I understand it. I just crippled by like, you know, the tech.
That's totally normal. It really is.
Yeah. Cool. Awesome. All right. I'm going to let you go, or I'm going to go.
Yeah,
you guys have a wonderful night.
Slack me whenever.
I will. I'm just gonna put that out there and then reach out whenever you get time.
Okay, sounds good.
Thank you.
You're welcome.
Bye.
All right, guys.
See you later, man.
Bye, guys.
Thank you, everyone.
Have a great night.
You too.
See you.